Chapter 5, Section 3, Proportions. Before we can define a proportion, we have to understand that an equation states that two quantities are equal. So we have something on this side of an equal sign and something on this side of the equal sign, and that is an equation saying whatever's over here is the same as whatever's over here. And we've seen this already in something like equivalent fractions. 1/2 equals 3/6. We know that 1/2 is the same as 3/6. This is the same amount on both sides, only we've written it in a little bit different manner, but we know that these two are equal, that 1/2 is the same as 3/6. Well, we also can see that if we multiply this numerator by this denominator, this is called the cross product, then we get 1 times 6, and that has to equal this denominator times that numerator, or 2 times 3, and in this case 6 does in fact equal 6, and that's how we know if these are equivalent. We find the cross product. So the cross product helps us know whether or not these two are equivalent fractions, and we actually learned that or saw that back in chapter 2. So that gives us, we have an equation and equivalent fractions just as an example of a kind of an equation. And we can look then at a proportion. And a proportion is an equation that states that two ratios or rates are equal. So we have on one side, A is to B, a ratio of A to B equal to the ratio of C to D. So we know that these two ratios are the same because we have an equal sign in between. And again, knowing that cross product, we can look at the cross product, and in general terms, we know that two proportions or two ratios are equal, and a proportion is true statement if the cross product is true. So that would be AD equal CB. In other words, this numerator multiplied by that denominator and this denominator multiplied by that numerator, that those two quantities have to be equal for that to be a true statement. And so we can go ahead and look at different ratios and determine whether or not they are actually true statements. So we have 3/5, and we want to know, is that the same as the ratio 9/15? Now there's several ways to look at this, and you can say in your own mind, thinking about this, what did it take to multiply 3 to get to 9? Well, that would be 3. So 3 times 3 is 9, then we have to take 3 times 5, which is 15, and we can see that this is indeed a true statement. So this we would say is true. Now, sometimes we can't see it so easily that way, and so we learned, we use the cross product to determine if or not, if something is true or not. So, for instance, we could look at the ratio 5/12 equal to 30/70 seconds, and see if that is indeed true. So we take 5 and we multiply it by 72, 5 times 72, and we see, is that equal to 30, or equivalent, the same amount as 30 multiplied by 12. So 5 times 72, we take 5 times 2, that's 10, we carry our 1, 5 times 7 is 35, plus 1 is 360, and on this side I have 12 times 30. I put the 0 for the placeholder from the 3 times, from the 30, 3 times 2 is 6, and 3 times 1 is 3, so we get 360 equal to 360, and that too is a true statement. And we know that those two are equivalent proportions. So now what if we only knew some of the pieces and we didn't know all of them? Could we find the missing piece? So let's say we had 2/3 equal to t over 18. In this case, the thing we don't know we've marked with the letter T. And so we can look at this and look at the cross product. So 2 multiplied by 18 would have to equal 3 multiplied by T. So we have this relationship, and then in order to find what T is, we want to isolate T, and so we have 3 multiplied by T. We want to get rid of that 3 or undo that 3 or create this just to be create a 1 here, and so T is by itself. And in order to do that, we're going to divide this by 3. That's going to give us just T on this side. But in order to keep the equivalency here, in order to keep the balance of this equation, whatever we do to this side, we have to do to this side. So I am going to in turn divide this side by 3. This cancels to be a 1, and we can eliminate those 2 common factors over there. We're left with T on this side, and we have 2 times 18 divided by 3 on this side. And we can multiply our 2 by the 18 to get 36. 36 divided by 3. So this would just be 12 equal to T. And then we can go back and check in our original answer and see if that makes sense. Well, even looking at this, we have 3. We know we can multiply 3 by 6 to get to 18. So then if I multiply 2 by 6, I would get also to 12. And so we think that we have done this right in just checking our answer here. So 2 times 6 is 12, and 3 times 6 is 18. So 2/3 is the same as 12/18, and our answer does in fact make sense. All right, so let's look at another one. In this case, we'll look at a little bit more complicated one, and that will have a decimal in it. 4 3/4 is to 8 as 9 1/2 is to K. All right, so this is the same kind of problem. We can take our cross product, 4.75 or 4 3/4 K would equal 8 times 9 1/2. All right, so I'm going to get rid of the 4 3/4 on this side by dividing by 4 3/4. That'll give me these 2 canceling, and that would go to 1, so I only have 1 K on that side. But we have to make sure things stay balanced and write that over here also. And so we have K equal to, and we could also just use our calculator at this point to calculate this, what we're looking at here. So we have 8 multiplied by 9.5, and then we're going to get that answer, 76, and we're going to divide 76 then by 4.75, and that equals 16. So we believe the answer here, K equals 16. Well, let's check that. Let's see if that makes sense. 4.75 is to 8 what 9 1/2 is to 16. Well, now I can see 8 times 2 is 16. What's 4.75 by 2? Does that make sense? 4 3/4 multiplied by 2. Well, I know 4 times 2 is 8, and 4 times 3/4 would be 1 1/2. So 1 1/2 and 8 would be 9 1/2. Oh, cool. That's great. It is, in fact, equal to what we're looking for. So this does, in fact, make sense, and our solution, K equals 16, appears to be the correct answer.